Okay, so today I'm going to talk to you guys about charges and static electricity. If you notice here first, it tells us that a charge can be positive like protons or negative like electrons. If you remember back when we talked about the parts of the atom, remember that we talked about that you have positive charges in the center of the atom, those are our protons, and we have the electrons outside. Those are the ones that are orbiting the outside of the nucleus, and those are our electrons, and they're negative. If you look, there's two things that you need to know about charges. Hopefully, you guys are already aware of these two statements, but the opposite charges attract. So if you have a positive and a negative, then they're going to come together. And then like charges repel. So if you have a positive and a positive or a negative and a negative, they want to repel one another. I tell you guys to always think about magnets because most of you are most familiar with magnets at some point during your schooling. You've learned that when you try to take two magnets and put them together, they'll either come together or they'll repel. And the closer you get them to each other, you'll feel that attraction or that repulsion. Magnets are a little bit different because magnets deal with different poles. You have a north pole and a south pole, but it has the same concept as you would with your charges of a positive and a negative. All right, the electrostatic force is based on the strength of the charges and the distance between them. So a big charge in a small distance would equal a large force. Again, if you think back to your knowledge about magnets, if you think about the closer you get them together, you can feel that attraction or you can feel that possible repulsion. So that helps you to understand that that small distance causes them to come together or push apart. Whereas if you were to hold those magnets out further, you wouldn't feel that attraction or that repulsion. And then, of course, if anything's bigger, like a bigger charge, it's going to, of course, have a stronger attraction or a stronger repulsion from each other. With static electricity is created by losing or gaining a charge. You do want to recall back that only the electrons are the particle of the atom that's going to be moving. Remember, your protons and neutrons are in the nucleus and they're not moving. So the electrons are the ones that are going to move. I also try to tell you guys to remember that electrons, electricity, and typically it'll help you to remember that it's the electrons that are the ones that are moving. Static electricity is caused by friction, and you know that friction is anything that it opposes motion. So if we were to take a balloon and a wool sweater, or possibly the balloon in your hair, if you were to rub them back and forth and cause that friction, then the electrons from the wool would be moved to the balloon because they were rubbed together. If you look at this diagram, you should also notice that the electrons moved from the wool sweater to the balloon. So that means the balloon gained negative charges. So overall, the balloon would now have a negative charge. The wool sweater lost those electrons. Those electrons were transferred over to the balloon. So therefore, the wool sweater would have more positive protons. So therefore, the wool sweater would have an overall positive charge. All right. If you look here, it kind of sums all that up for you guys. It just shows you that if it has a positive charge, that means it's lost electrons. If it's neutral or no charge, it has an equal number of protons and electrons. And then, of course, if it has a negative charge, that means that it has gained electrons. All right, why do these examples create static electricity? So if you look here, you see that with thunderstorms, hopefully you guys know on the next little slide here, it shows you that in the clouds, you have a negative charge. On the ground, you have a positive charge. And we know that with a positive and a negative, that they do become attracted. So when they become attracted, we have that, lightning or whatever, the rolling thunder. The second example was a little girl sliding down the slide. So just remember that with sliding down a slide, of course, that's friction. So you can see here that her little hair is kind of standing up on its ends. All right, and then finally, let's talk about how objects can gain a charge. So there's three different ways that objects can gain a charge. They can gain it through friction. Of course, what we just talked about that, so that opposing of the motion can transfer those charges. But there's two other ways. We have conduction and induction. Conduction is when the objects touch and the charge transfer, and induction is charging a neutral object by bringing a charged object close to it. So with conduction, I try to tell you guys, just remember conduction is where they touch. If we were to cook some noodles on a stove, or if we were to boil water, we would have the pan that's going to touch the actual stove. So that's cooking through conduction. So that's a transfer of heat through conduction. So it's just when the objects actually touch. Induction, they're not going to touch, but that bringing it close to it will cause it to charge it up. All right, there's the electroscope. I do have an electroscope that I can show you in class one day. But the electroscope can detect a static electric charge. What happens is you have these metal leaves that are at the bottom, and then it's got just some type of metal hook to it. And what you can do is we could take like a balloon that maybe we charged up by rubbing it against our hair. But if we bring a charged object close to it, for example, here in this diagram, if we bring a charged object close to that electroscope, then we know that the positive charges are going to be attracted to the negative charges inside this electroscope. So what happens is all the negative charges come up, all the positive charges are pushed down. And we know that a positive and a positive want to repel each other. So since both of these metal leaves are positive in charge, then they're going to separate out. So it tells you here that when you touch the electroscope, the electrons are attracted to the positive charge that leaves the protons on the metal leaves, and they have the same charge, so they will repel. The same thing could happen in reverse. The charged object could be negative, which would then attract all the positive, making all the negatives go to the bottom. So it really just depends on what type of charge the object is that you're bringing towards the electroscope. Conductors and insulators. With our conductors and insulators, these are, again, you can think of when you're cooking, so you can think about the conduction of heat, but with electricity, when we talk about conductors and insulators, the conductors allow the electrons to flow. So these are, of course, any type of metal. So like copper or gold, that's why we use in wiring, we'll use some type of metal because it does allow those electrons to flow through. Insulators do not allow the electrons to flow. So this would be something like rubber or plastic. So that's why we coat our wires with some type of plastic coating or a rubber coating so that you can grab a hold of that cord that may be attached to your computer and it won't electrocute you. And then, of course, you guys should remember the semiconductors. The semiconductors are those that live along the stair step off of the periodic table that we talked about back in chemistry. And the semiconductors allow some of the electrons to flow. That most noted semiconductor that is used is silicon. And I'm sure that you guys remember me talking about that at the beginning of the year.